Hello and welcome to another lecture on conic sections. Today we're going to start out with a review problem from the previous day. Now this is an ellipse. It moves one out in each direction, four up and four down from its center. So if I'm going to write this in standard form, an ellipse is always written like this in standard form, where the right hand side is equal to 1, and each of these, the x and the y, will have some number squared. Now in the x direction, we move to the left 3, so we'll need a plus 3 in there. And then we'll move out 1 in each direction. So we'll put a 1 down there. We don't need the over 1, we could have just written x plus 3, but that's all right. Now in the y direction, we go up 2, so that's minus 2, and then we stretch it by a factor of 4. So our entire equation is x plus 3 squared plus y minus 2 over 4 squared plus 1. Now what type of graph will this be? Well, our y squared doesn't have a coefficient. Our x squared has a negative coefficient, so we know it's going to be a hyperbola because they have different signs. Now to write the standard form for each graph, we talked about that yesterday, so we don't need to go through that. All right, now we'll start up with the worksheet. You should know all of the squared numbers from 1 to 20. Take a minute and fill that out. Now if we have x minus 3 squared, that's the same thing as x minus 3 times x minus 3, which we can FOIL that out to get x squared minus 6x minus 9. We call this a perfect square because if we square something, it will turn out to be like that. Just like these are all perfect squares, this is also considered a perfect square. So can you fill out the next page? To do number 1, it would be x squared minus 4x plus 4. Y plus 9 squared is y squared plus 18y plus 81. This last one, to just do a general sense, this would be x squared minus 2hx plus h squared. Regardless of what h is, this will be the form it always goes in. So we'll square 9 to get 81. We'll multiply it by 2 to get the middle term. We'll multiply negative 2 by 2 to get negative 4, and we'll square it to get the last term. Now if we're going in the opposite direction, this will be x plus 6 squared, and that's because half of 12 is 6, and the square root of 36 is 6. This one we'll do x minus 1 squared. How can we easily find important information from these equations? Now, the standard form is really easy to find important information and how to graph it, but equations like this are pretty difficult. So we need to find some way how we can write these so we'll be able to graph them. First, we have to figure this out. If x squared plus 10x plus something is going to be a perfect square, we have to think about what number we can fill in here to make it a perfect square. The answer will be 25, because the perfect square here is x plus 5 squared. We multiply 5 by 2 to get this, and square it to get that number. If you take a look at this, what number would we have to fill in here? Well, first the square would be x minus 6 squared, so this would be 36. This one gets a little tougher. This is 3 halves. If we square that, it would just be 9 fourths. It's a little trickier when we're using decimals. If I would have said this is 1.5, then you have to think about what 1.5 times 1.5. It's a little bit easier with fractions in this case. 1.5 times 1.5 is 2.25, but it's a little easier with fractions. Now in this case, half of this will just be 6/14. And then if we square that, we'll get 36/96. All right, so fill out this page and figure out what numbers to fill in both blanks. Now we're going to look at a little bit more complicated problem, getting closer to where we want to be. Now if I start with this and I say 5x squared plus 30x, I can factor a 5 out, leaving x squared plus 6x. Now the problem is I want to turn this into a perfect square. So we have to think about what we need to add here to make this the perfect square. Well, half of 6 is 3, and 3 squared will be 9. Now, if I add 9 to the left-hand side, I have to do something to the right-hand side. The problem is that I'm not just adding 9 to this side, I'm adding 9 times 5. So really, I'm adding 45 to the left-hand side of this equation. So I have to add 45 to this right-hand side of the equation. So to finish this, this would just be 5x plus 3 squared equals 52. If we do the same with this, this would be y squared minus 10y. Think about what we need here. Well, we know our perfect square has to be half of this, so y minus 5. If we square that, that would be 25. So I'm not adding 25 to this side, I'm adding negative 3 times 25, which is a negative 75. So negative 75 would be in that blank. Now for number 10, you factor out a 4 to get x squared plus 2x. I'll have to add a 1 to make that a perfect square. And I'm not adding a 1, I'm actually adding a 4. On number 11, if I factor out a 6, I get this situation. To make this perfect square, it's actually a 16. And then 6 times 16 is what we put on this right-hand side. 6 times 16. Let's think about that for a second. I don't know that off the top of my head. 96. So if I add these together, I'll get 108. Now this one, I have a couple different things that I'm trying to find the perfect squares of. So first thing I do is put my x's together. X squared minus 2x, 1 over here. And then if I put my y's together, y squared minus 2y goes there. So what I need to fill in here would be a 1, because it's x minus 1 square. And here also, I fill in a 1. And I'm not multiplying either of those by anything, so I can just put a 1 on both of those and add those up. So this would be x minus 1 squared plus y minus 1 squared equals 3. Now if you look at this equation, hopefully by now people see that this is a circle going to the right 1, up 1, and it has radius as the square root of 3. Now in this one, we can tell right away this is a hyperbola because there's a positive and a negative sign. I put the x squared minus 2x together. I'll put in a 1. Y squared minus or plus 2y. I'll put in another 1. Now here I'm adding 1 and that becomes a negative 1. So it's plus 1 minus 1. So this becomes x minus 1 squared minus y plus 1 squared equals 1 plus 1 minus 1 is just going to be 1. So this is a hyperbola with a center at 1, negative 1. Now we have to do the whole problem. So the first thing I'll do is put my x's together. Negative x squared plus 4x plus my y squareds together, or my y's together. And then I'll put this on the other side, equals 1. Now you have to think, what do I need to add to this to make it a perfect square? Or first I have to factor out a negative. So if I factor out a negative, this would be x squared minus 4x. Now this one you don't have to factor out a negative, which makes it easier. So what I need to add in here would be a 4, because half of 4, negative 4 is negative 2, negative 2 squared is 4. Over here I'd put in another 4. So really what this is a negative 4, and this is a plus 4. So those cancel out. And so we'll have negative, this is x minus 2 squared. This side would be y minus 2 squared. 1 minus 4 plus 4 will just be 1. Number 15. It's nice that our x's are together, our y's are together. Let's just move this 4 on the other side. So I have x squared plus 4x plus something plus, let's take a 4 out of both of those. So y squared minus 2y plus something is going to equal negative 4. Now, here I'd have to fill in a 4. I'd have to fill in a 1 to make these perfect squares. So this would be adding 4 more. So I'll add both of those 4s in. So now this is x plus 2 squared plus 4 times y minus 1 squared equals 4. Now remember, for ellipses, to put it in standard form, this right-hand side has to equal 1. So if we divide by 4, this is going to be x plus 2 squared over 4. Over here, 4 divided by 4 is going to cancel out, so it's just y minus 1 squared equals 1. And now our last step is to put this 4 into the parentheses. So it's kind of like we have to take the square root of it. In order to have this equivalent to that. And this is our equation in standard form. Now determine whether each equation represents a circle, ellipse, hyperbola, or parabola. Complete the square to put the equation in standard form. Then find key information to sketch the graph. So on this one, we'll first put our x's together, our y's together. And before we start that, we can determine what this is. Since this is positive, that's positive. We know that it's not a hyperbola. Both of them are squared, so it's not a parabola. And they're different coefficients, so it can't be a circle. And we know it has to be an ellipse. So now we have to complete the square to find out how to graph this. 9x squared minus 18x plus 4y squared plus 16y. I'll move that 11 on the other side to make it look like this. So now I factor out the 9. And over here I'll factor out the 4. Now what we'll have to add to this one is a 1. To make it a perfect square, this one we'll have to add a 4. So really what we're adding on this left side is a 9, and over here we're adding a 16. So now I'll have 9. This in perfect square form is x minus 1 squared. This in perfect square form is y plus 2 squared. And the right-hand side is 36. Now to put this in standard form, we need to divide by 36. So this will be x minus 1 squared. 9 over 36 is the same as 1 over 4. 4 over 36 is the same thing as 1 over 9. And now if we want to put these in parentheses to make it all in standard form, x minus 1 over 2 squared plus y plus 2 over 3 squared is equal to 1. Now if we wanted to make a quick sketch of that, we go to the right one, down 2. That's the center of our ellipse. It stretches out 2 to the left and 2 to the right. And now we go up 3 and down 3 from the center point. Now to draw our ellipse, we just connect all 4 of those vertices. And hope that you can draw an ellipse better than I can. Alright, now I'll let you try to figure out how to do the rest of those. And good luck.